Hello, and let's prepare to cycle back through cross-country cycling. Today you were given a handout. Please cut out the rectangular Frere model for your ISN. We will complete each block over the next few slides. Please pause your video as we go through each slide in order to write down your definitions and any other important information you obtain from this video. Let's first talk about the definition of a linear relationship. A linear relationship is a relationship that is graphed as a straight line. If we think about characteristics of a linear relationship, one characteristic is that the graph is a straight line. There are no bends or curves in the line. Another characteristic is the table has a constant rate of change. Remember that a constant rate of change is delta y divided by delta x, and it is the same between any two ordered pairs in the table. Let's look at a few examples. Please copy this table down. As we look at this table, we notice that the change in y, which is 2, divided by the change in x, which is 1, is 2. The change from 1 to 3 is 2, and the change from 0 to 1 is 1. So 2 divided by 1 is 2. This table is an example of a linear relationship. Here is another example of a table that it has a linear relationship. The rate of change between any 2 points on the table will be the same, making it a straight line when graphed. We can also look at examples of a linear relationship on a graph. Please notice that these two lines do go through the origin, so we can categorize them as proportional, but both lines are straight, meaning they have a constant rate of change. Two other examples of linear relationships show that they do not go through the origin, but going through the origin does not determine whether a relationship is linear or not. In order to be linear, it must be a straight line. As we look at some non-examples, we have a table. Please pause to fill in these fact points. In a nonlinear relationship, the rate of change is not the same. So as we calculate our delta y and delta x and then simplify, 2 divided by 1 is 2, but 3 divided by 1 is 3. So there is not a constant rate of change. Another table. As we calculate the delta y and the delta x, the rate of change is negative 1 divided by 1, which is negative 1, but a positive 1 divided by a positive 1 is a positive 1. So my rate of change between any 2 points is not the same. These two tables are examples of non-linear relationships because the delta y divided by the delta x is not the same for each row. Here are two examples of non-linear relationships. If we notice, even though our lines are straight on this first one, it must be one straight line. And this red line contains 2 lines. As we look at the green set of ordered pairs, there is a curve or a bend. Again, it is not a straight line with a constant rate of change. And then our purple line has 2 bends in it, which means there is not a constant rate of change. So as we reflect back in your notebook, please tape or glue down the information we just copied on your slides and title the page Linear Relationships. On the left-hand side of your page, please write down these 2 questions. The first one being, are all proportional relationships linear, and how do you know? Please take the time before class tomorrow to answer this question. The second question, are all linear relationships proportional, and how do you know? These questions should be answered before you come to class. We will go over the answers to both of them, and that way you will be able to determine if you are correct or not. Again, if you need to watch this video, please go back and pause as many times as you need in order to write down all the information. We will discuss this in class and answer any questions you may have.